Welcome to qnawire.
All right, so for the first part of this, it gives us the hint that carbon's a central atom. Carbon is usually a central atom because it forms the most bonds. So we have a carbon, and we need to attach three things to it. We've got an oxygen, and we've got two chlorines. And now we know that carbon wants to form 4 bonds. So far, it's only formed 3. And oxygen wants to form 2 bonds, and so far, it's only formed 1. So we can draw an extra bond in here for oxygen. And now remember the lone electron pairs. Chlorine needs a full octet, as does oxygen here. So in terms of the hybridization, since we have 3 things around it, this will be sp2 hybridized. We can draw in that extra p orbital, something like this. It exists between the carbon and the oxygen because they're the ones forming this double bond, and label red as our p. For this bromine with 5 fluorines around it, we're going to have to break the octet rule here because it's got more than 4 things attached to it. So let's draw our bromine with 5 bonds to fluorine. And we should also keep in mind that bromine has 7 lone electrons, or 7 valence electrons. So if we use 5 for bonding, 2 of them had to be in a lone electron pair. That accounts for all 7 of them. Now we just need to account for the octets on fluorine. There. And now we need to label all these bonds. So the bonds from fluorine are going to be sp3 because they've got 4 things around it. The bromine, you can count 1, 2, 3, 4, 5 bonds in a lone electron pair. That makes it sp3, total of 4. We need to get to 6, so we need 2 d orbitals this time. Now we've got xenon, which is a noble gas. It normally doesn't bond, but it can bond to fluorine in this case. So xenon normally has 8 lone electrons around it, which is why it doesn't like to bond. If we use 2 of them for bonding, we're left with 6, which I'm going to draw in like that. And of course, we don't forget the electrons around the edge of fluorine. So the fluorines, like all the fluorines, are going to be sp3 here because they have 1 bond and 3 lone pairs. The xenon has 2 bonds and 3 lone pairs. So instead of being sp3, we need an extra orbital, which is going to come from the d. That's sp3d. Now we have 3 iodides. So one of them is going to be our central one. The other 2 are going to be terminal. For the terminal ones, it's really easy since it has 7 valence electrons. If it forms 1 bond, it just gets a full octet. However, for the central one, we can't do that. It's forming 2 bonds, which leaves it with 5 left over. So I'm going to draw it like that. And normally we really hate to have radicals, so we double check, and if you multiply 3 by 7, you get 21. That's an odd number. Since it has an odd number of electrons, you're always going to have a radical somewhere. So that radical still has to go into an orbital, so we can treat this central iodine like it has 5 things around it. Even though it doesn't have 3 lone electron pairs, it has 2 full pairs and a half pair, which counts. So since it has 5 things around it, it's going to look just like our xenon compound. It's going to be sp3d, and the outer iodines are going to be sp3.